So in this video we're going to look at organic chemistry, and we're specifically going to look at addition reactions. So our learning intention is to explore addition reactions, including their mechanism and the chemistry behind them. So let's dive straight in and give a definition of our addition reactions. So an addition reaction is one in which two or more molecules react together to produce a single molecule. And examples include the addition of hydrogen, chlorine, bromine, hydrogen chloride and water to ethene. The addition of hydrogen to ethene is known as a hydrogenation reaction. So the best way to understand an addition reaction is to do an example. So we're going to look at the reaction between ethene and bromine, and this reaction has 4 steps. The first step is called polarization, and as we can see here from our diagram, the carbon-carbon double bond is a region of high concentration of negative charge. And as the bromine that's here becomes close to the ethene and the double bond, it becomes polarized due to the repulsion of the electrons in the double bond. Step 2 of this reaction is called heterolytic fission. And here, the induced polarization on our bromine molecule becomes so great that the bromine molecule splits into 2 ions, a Br- and a Br+. So we can see here that 2 electrons end up on 1 atom, as we can see here with our Br- ion, and this is called heterolytic fission. So step 3 of this reaction is called the carbonium ion formation, and here the Br+ attacks the ethene in order to gain 2 electrons to have a full octet. So the Br- ion forms a covalent bond with one of the carbons using the 2 electrons in the double bond. As one of these electrons belonged to the other carbon, it now has a positive charge and is called the carbonium ion. And we can see this here in our product, that the 2 electrons have now gone and formed the carbon-bromine bond, and our carbon down here only is 3 bonds, so it's called a carbonium ion intermediate. The carbonium ion can also exist as a cyclic structure called the cyclic brominium ion. The final step of this reaction is called ionic addition, and in ionic addition the carbonium ion is attacked by the Br- ion, and this results in the formation of 1,2-dibromoethane. So we can prove that this addition reaction occurs by reacting ethene and bromine water that contains sodium chloride. Now, if we were to do this reaction, we would get the 1,2-dibromoethane as expected, but we would also get 1-bromo-2-chloroethane. And this is formed when the carbonium ion is attacked by the Cl ion, and this hence proves the existence of the carbonium ion intermediate. So another product that will be formed is 2-bromoethanol, and this will be formed when the carbonium ion is attacked by a water molecule, and this further proves the presence of our carbonium ion in this reaction. If we were to complete the reaction between ethene and chlorine, we would follow the same mechanism as we've just discussed for bromine. And if we were to do the reaction between ethene and hydrogen chloride, again, it will be the same mechanism as we've just discussed for bromine. However, the explanation for the polarization in this reaction would be that the HCl is already polarized, and it gets further polarized by the electrons and the repulsion in the double bond. So there's many uses for the products of addition reactions. An example of a use of dibromoethane is as a fumigant for treating timber logs against termites and also controlling moths in beehives. A use of 1,2-dichloroethane is in the production of chloroethane, which is then used to make PVC, which is discussed in another video on this topic. And finally, chloroethane is used in dentistry to diagnose a dead tooth. So that's it for this video. Have a read over the learning intention to make sure you understand everything we've gone through.